Not recording yet. Okay, now recording. Sweet. Welcome in, everybody. Good, Sarah. I'm glad to hear that. Everyone have a good weekend. Let's start off this session on a little different note, kind of a la our three good things that good. I'm glad to hear that y'all had a good weekend that we would do when we were together because I miss those days. So, anyone have anything they want to share? Anything fun? Anything exciting they did over the weekend? A deviation, a change up from the norm, I guess you could say. Dad made cookies. Nice. Cookies are always good. What kind of cookies? We've got a lot of cookies being made. Right on. Cool, cool. I made banana bread. It's pretty good. Chocolate chip. Nice. Welcome in. Welcome in. Who's CB? Who's taking that name? Oh, Christian, what's up? You're good. Makes sense now that I know. I just couldn't gather what initial CB would be, but welcome, Christian. All right. So other than cookie making and hanging out, anyone have anything else I want to share? Take some time to kind of talk about that. Try to reconnect on a personal level as opposed to just jumping straight into our beloved zero product property that we're going to do. Oh, happy 19th anniversary to your parents, Sarah. That's awesome. Sure, a very different anniversary than they're used to having, being that everyone was stuck inside more or less. Sweet. Okay, hey, well, if you have anything that you did over the weekend that you want to share, no hesitation, just throw it in that chat box. We'll give it a shout out. But other than that, then let's get this party started. Saw a concert online. Very cool. That's awesome. That sounds like a good way to spend a weekend for sure, or someday. What did I do this weekend? Thank you for asking, Sarah. Did a little bit of work, not too much work. I got to try to skirt the line there between that. I actually also hesitate to say this, but I left my house this weekend. Still maintained good social distancing etiquette though. And I went over to my buddy's place, went through the side gate, maintained distance, and I helped him set his climbing wall. He built a climbing wall out of plywood, and I went over there and I helped him. I know. You're not getting a tattoo. Yard work, slept through half your classes yesterday. Oh, well.
I swear I am. I swear I am.
You swear you're getting a tattoo?
Yeah, I have a 3.0. As long as I keep my 3.0, I can get a tattoo.
Your dad's okay with this?
Yeah, we already talked about it. He says as long as I keep the 3.0.
What are you gonna get?
Most likely like a tribal war dragon.
All right, you got to show it to me then.
I got you. I will.
Okay, I'll expect to see it when we come back from summer.
All right.
All right. Hey, keep that 3.0 up, which actually is going to take me into kind of a conversation. So how about this? We'll move into our announcements for today. Once we finish with today's lesson, it's actually a review lesson from something we did in the first semester. We can go back into other conversations about what we did this weekend, okay? Awesome. Glad to hear that you can hear now. Okay, Ed Puzzles. Two are due this Friday. It's like a cascade of Ed Puzzles lately. So I've noticed a lot of you have been doing it. Great job. I love it. So we have some more due this Friday. Posted one this morning. I guess you could say this morning, really like at midnight, called the Zero Product Property, which is what we're going to learn about today. But the main reason why I'm talking about the Ed Puzzles is not to talk about all the ones that are coming up, but actually the ones that are already past due. On the announcements here, that's number 1, part C, what I've classified as old Ed Puzzles. So those are still available. So just because were due, say, April 17th or April 13th or whatever they were, doesn't mean, sorry about that, doesn't mean that you still can't do them, all right? And they're still there and they're graded on completion, kind of like homework. They are akin to homework and classwork. So whether you get a 1% or 100% on them, you're going to get 100% credit if you do a majority of them. Now, what I mean by do a majority of them is the following. The very first we finished module 3, which was on transformations. We kind of were just about finishing that before we went to remote. So we had 2 ed puzzles that related to transformation concepts. I think they were called like parent graphs and 6 basic functions. Those 2 are related to the module 3 ed puzzle. So if you were to go onto your Infinite Campus, you should see a 4-letter, well, 3 letters, 1 number kind of category that says M3EP. It's worth 10 points. That stands for module 3 ed puzzles. To get those 10 points, you have to do both ed puzzles. If you did one, you're not going to get credit for it, okay? Because you only did half the work. Now, that being said, it's not going to hurt your grade. You're just not going to get any score in there. No help, no hurt. But if you did both ed puzzles, or if you haven't done them and you go back and you still complete them right now, you're going to get completion credit, okay? So the big reason why I'm kind of bringing this up right now is, as you can see, number 4 on the announcement page. We'll get to that in 1 second, but grades are coming up. And also, I want to encourage y'all to do the ed puzzles. It's effectively a way for you to get some practice help with the math above and beyond coming here. But also just kind of to say, get that in. If you haven't done it, go back and do it. You'll get credit for doing it, okay? I don't know what that means, Jeff. Sorry. I know what no say is, but I don't know what the other word is. Give me that translation. Okay. Next up, RLA and RLQ. I say them every single class. Remote learning agenda, remote learning questionnaire. The RLQ is this thing right here. Boom. Okay. This thing that I post every week on a lot of posts. Fill them out. Got questions. Look at someone already asked me a question earlier today. I got back to him. We are all good on that. Never hesitate to ask me questions in person here, over email, or on the RLQ. Make sure we get those filled out. I'll try to get those back to you ASAP. Been trying to answer a lot of homework questions on that I've been getting on that as well. So always check back to the YouTube. Cool. That's the RLQ. The RLA, the remote learning agenda, is this beautiful little thing. Also attached to many of my classroom posts, this is effectively a consolidated, meaning a short way, so we can see exactly what we're doing every single day and due dates are. So notice today is 4/21. What are we doing today? Once we get through all these announcements in our WhatsApps, we're doing lesson 11, which is on zero product property. Hence why Ed Puzzle posted on midnight last night for that. Hey, when's that homework being done? Oh, today in class. Cool. But when is it due? 5/5, Cinco de Mayo. Look at that. You're here. We're going to get that homework done today. So you're probably like, all right, no more announcements. Let's do the homework. We will. But finishing our announcements now. Extra Zoom session. A lot of y'all attended on Friday. Much love for you for doing that. It was nice seeing y'all. Also helped me kind of check a box that I needed to get done. And if you want to come in on Zoom sessions Fridays at 10 a.m., check them out. They're not our normal class sessions like today and Thursday, but they're really just set up to answer homework questions. Or if no one has any homework questions, I'll just be sitting here on Zoom doing work. But if you want to come in and just say hey and talk, I would also love to do that with you as well. Okay, so yeah, thumbs up on that. So check it out if you want to join. If not, no stress. Last but not least, 4th quarter progress report grades due by Monday at noon. That's on me. The reason I'm telling you this is because you will get progress report grades on Tuesday, and it will include everything that you turn into me by Monday. Okay, I'm going to get those done Monday morning and then posted before noon. So get everything done, which is actually why I kind of transitioned, or started with rather, on our announcements on the Ed Puzzles, because I want to encourage y'all to get those in if you haven't done them, so I can boost up that grade. One last thing on grades, then I'm going to go into questions. But one last big thing on grades here, as I kind of navigate my notability here, is the following. Here's the situation. So this is what I did for Algebra 2 Trig. Just going to get rid of all of this. Actually, you know what? We'll leave this. Okay. Here's what's up. Originally in the semester, this was how our grade were broken down. All right. So when you came in January and we were expecting to be together the whole rest of the school year, this is how it was set up. Homework was 10%. Quizzes, the homework quizzes were 10% of your grade. Tests, the heavy hitter, those projects, those assessments that we were doing, 60%, and then the final was set up for 20%. However, since we've gone remote, things have changed, obviously. So what I did on Friday is I tried rearranging the categories at which I score your homework, I reclassified things. And here's what I did. I eliminated the final grade. Now, that doesn't mean we're not going to have some sort of assessment at the end of the year, but here's what happened. Basically, what I did is I said, all right, final, you're kind of useless at this point because you're not as applicable. We don't see each other every day. We're not going to be as prepared to take a 40-question test or a 30-question test like we did in the first semester. It's not fair. So I reclassified that 20% of the final into 2 categories. Remote homework assignments, 10%, and remote assessments, 10%. So for those of y'all that did that transformation assessment, the Unit 7 transformation assessment that was due by Friday, that actually got dropped straight up into there. So that was actually going to be super, super useful for y'all because it's basically like saying I made it worth 1 point and everyone at least got 2 points on that if you did it because it was extra credit. So that's a really big jump because what basically just happened here when I reclassified that final into 10 and 10 is the following. Everything that you turned in before we went remote fell in that blue box, the homework 10%. Everything, every assignment, including Edpuzzles and all the textbook assignments that you've turned in since then, has gone in this green box, which basically means the following, that for this semester, you do your homework, that's 20% of your grade, okay? All of the quizzes that we did before going remote are here. So right off the jump, 30% of your grade is just, hey, are you doing your work? Are you here? Are you present? Are you trying? Right there. So that was I did this in an effort to try to make things a little bit more consistent and fair based on the given situation and the difficulty of online learning. So hopefully that helps out. Anything that we do in terms of assessments, AKA tests, which won't be a lot, but more so projects moving forward, are going to drop into that remote assessment box, which is basically worth 10% of your grade. It has the ability to hopefully more easily move your grade up rather than the opposite, move it down. The goal is not to move any grades down, y'all. The goal is for y'all to work hard in conjunction together with me and try to get the school year done on a positive note, okay? So that's why I reclassified it. I just wanted to give you that heads up if you've been looking at your Infinite Campus. That's kind of why things have subtly changed, okay? All right. Then on that note, that's all of my announcements. So let's do the lesson for today, which is lesson 11, the zero product property. And actually, this is a complete reiteration of something that we did in the first semester, way back in the day when we were learning how to work with equations. We did something called the zero product property, which was a fancy way of saying, if you ever have a multiplication equation and it's equal to 0, we set the factors equal to 0. That might ring a bell. If not, hopefully today's lesson will. So what we're going to do is we're going to start off on page 501. We're going to learn a little vocab, and then we're going to get to some of the assignment problems. So without any further ado, page 501, here's what we're seeing. Okay, not that, but, oh, sorry, wrong unit. Keep going back to the last unit because I'm so used to doing successive problems, and now I'm all over the place. All right, take 2, 501. Those are the 3 things that we're talking about today. Zero product property, what something looks like to be in factored form. By the way, we'll be looking at that on lesson 14. And then horizontal intercepts, which is a fancy way of saying the x-intercepts. And we'll kind of go over that as well. That is basically what we're looking for, and all those things that you've seen, the roots, that Edpuzzle, that's another way of saying horizontal intercept. It's the x-intercepts. Okay, but for today, here's the big thing. We're going to reiterate what it means to find the zero product property by realizing if you have a multiplication problem, or as the book says it, if you have A times B and it's equal to 0, well then either both A or B have to be 0. There's no 2 ways around it, okay? And the reason for that is the following. If we have 4 times x and it's equal to 0, what is the only thing x can be equal to? 0. If you had x times, well, let's even use a different variable here, a times 3, it's equal to 0, what would you do? You would divide both sides by 3, and you'd realize that a is still equal to 0. And if you have two variables in a multiplication problem, let's call it c times d, and it's equal to 0, then the zero product property states that you can solve for either or both of those variables by setting the unknowns both equal to 0. Okay. Now that's effectively what the zero product property says in words. We're going to try to give it a little bit more insight into problems today by doing some practice problems in our homework. And then what we'll learn on Thursday and next week is how to do something called factoring quadratics. For those of you that were present on Friday, we introduced that idea. But if you weren't, we're going to learn that on Thursday and next Tuesday. And the whole purpose of the zero product property is to combine it with the opposite of FOIL, factoring, to solve for quadratics, equations with the power of 2, more efficiently and effectively. All right, without any further ado, let's move into lesson 11. Person who just private chatted me, I see you. I'll take that into consideration and I'll look into that. Okay, so thank you for that recommendation. All right, let's go to lesson 11, y'all. In lesson 11, we are going to start on page 525. 525. Okay, here we go. Again, I mentioned on the remote learning agenda, we're going to actually just go straight to the homework today. All right. Unfortunately, I didn't, shame on me, mark the problems that I wanted to do. Instead of jumping back and forth on my iPad, what I'm going to do is mark them here now. 1, 2, 3, 6, 7. And by the way, everyone, I'm getting this straight from the RLA, the remote learning agenda, right here. 1 through 3, 6, 7, 10, 12, 13. So just make those quick comments here. All right, awesome. Okay, let's go back. So we are on page 525. We're going to do number 1 right now. And here's effectively the zero product property. The zero product property states that if you have a multiplication problem, and guess what we do? We have 3 binomials. Ready? Binomial number 1, parenthesis number 1, times parenthesis number 2, times parenthesis number 3. If you have a multiplication problem, no matter how many factors, how many things are being multiplied by each other, if it's equal to 0, it is the best possible situation. And we'll learn actually how to use this and manipulate this later on in Algebra 1 and a lot in Algebra 2. But here's the gist of it. When you have a multiplication problem that's equal to 0, you take every single factor and you set them individually and uniquely equal to 0. Now, before I actually go about solving this, there's going to be 3 answers, but before I give you what those 3 answers are, you might be able to already see them. Does that kind of process look familiar to anyone from the first semester? When we were first learning how to solve equations, how to solve and isolate variables, working backwards using opposites, we ran into these multiplication problems, and I gave you a heads up back then that this would become super important at the end of the year. But guess what? We've reached that level of our journey here. So let's go. Now we've set them equal to 0. The best thing about these 3 multicolored equations now, which coordinate with the 3 binomials, aka the parentheses that were being multiplied by each other, is that they're all single step equations. Get rid of subtraction with addition. Do the same thing to both sides. First answer to this question is 1. Get rid of subtraction with addition. Do the same thing to both sides. First answer to this equation is x equals 2. And last but not least, get rid of subtraction with addition. Add 3 to both sides. Third answer to this equation is 3. Boom. That's the zero product property. That's the obvious application of it. Getting there is sometimes the hardest process, but we'll work towards practicing and mastering that as we move forward in the rest of this class. Now, let's take that and let's see if we can solve number 2. Right away though, before I even solve number 2, problem number 2, I don't want to know what the answers are. I just want to know how many answers am I going to have. Does anyone think they know the answer to that question? How many answers am I going to have here, number 2? Yeah, Francis, yeah, Caitlin, right on. We're going to have 2 answers. Here we go. The reason why they quickly said we'd have 2 answers is because guess what? We have 1 parenthesis, 2 parentheses, and guess what's happening between them? They're being multiplied and they're equal to 0. It's our best case scenario. Anything that's equal to 0 in a multiplication problem can be solved by setting the factors. And I'm using that word purposely, y'all. Factors are things that multiply together. So the things that are being multiplied together are these parentheses. The factors are set equal to 0. Keep in mind that I'm going to use that word factor continuously here for a purpose that we'll see on Thursday. Now, factor number 1, x minus 16.5 equals 0. Done. Set it equal to 0 and solve. Addition, undo subtraction. Add 16.5 to both sides. Money, x is equal to 16.5. Cool. Add 109 to both sides. Awesome. X is isolated. 0 plus 109 is 109. Cool. Sweet. That's how we solve zero product property problems. All right. On to the next one, number 3. And I know I'm moving relatively quick here, y'all, but if you need me to slow down or to go back to number 1 or number 2, type it in the chat box, unmute yourself, and we'll do so, okay? So, number 3. Can anyone take a guess as to how many answers this one's gonna have? How many answers to number 3? Ooh, 2 is a good guess, but it's actually incorrect here. And I know where you got 2 from. 1, 2 things right there, right? I see that. Yeah, Francis, there's 3 because guess what? There's another factor. There's another thing in the mix. That x in the front. So what we do is we take everything that's being multiplied, x times x minus 4 times x plus 5. We take every single piece of the multiplication problem and we set all of them, including just a standard x, equal to 0. Every single thing, even if it's not in the parenthesis, it can still be multiplied. And we set all the things that are being multiplied equal to 0. Does anyone have any questions as to how I got x equals 0 there? Why I set that thing equal to 0? Let me know if you do. Don't hesitate. I'll be happy to answer. Cool. One of these 3 equations is already solved. Look at, we already have x isolated. Sweet. There's one of our answers. This one needs a little addition to undo subtraction. Easy. 0 plus 4 means that x is equal to 4. This one needs a little subtraction to undo addition. Subtract 5 from both sides. 0 minus 5 on the right side of our equal sign gives us negative 5. X is isolated. Sweet. And what this basically does is allows us to really quickly and easily check to see if this is true. Our first answer was 0. So here's what we know. If you take all of these x's and we substitute, aka replace them with that first answer of 0, this x becomes a 0, x minus 4 becomes 0 minus 4, x plus 5 becomes 0 plus 5. This is just a quick check, y'all, with substitution. Let's see if it checks out. Ready? PEMDAS says we do parentheses first. Okay. 0 minus 4 is negative 4. 0 plus 5 is 5. Parentheses, done. PEMDAS. Now we can just do a string of multiplication. What's 0 times 4? Sorry, 0 times negative 4, it doesn't matter. 0. And what's 0 times 5? Does it equal 0? Yep, sure does. We could rinse and repeat the very same process, and I'm going to do so rapid fire right now. Now, what was my second answer? 4. So I'm going to take x in every single one of these, every single part of this equation. All of those x's, I'm going to substitute in our second answer of 4 for it. Ready? Color coordinated for our viewing pleasure. All those x's become 4. Sweet. PEMDAS says parentheses first. 4 minus 4 is 0. 4 plus 5 is 9. Guess what? It doesn't matter because you are multiplying times 0. All we're doing is we're really manipulating these problems to have one of our factors in the parentheses or outside of the parentheses be 0, because then it makes everything 0 out through multiplication. Last quick check. What was my last answer? 5. So here we go. My last answer was 5 right down here. So I make all of these x's in the original equation 5. Now we do PEMDAS. 5. 5 minus 4 is 1. 5. Oops, sorry, it was negative 5. Oops, my bad, -5. Let me go back up here. -5, -5, -5. -5. -5 minus 4 is -9. And -5 plus 5 is 0. It doesn't matter what PEMDAS tells us now. That's going to be positive 45 because once we multiply something by 0, it always equals 0. All right. Again, just quick checks. Little math check coming on. All right. Good progress. Number 6. Before we solve number 6, and you might have already solved it, can someone FOIL this for me over here? Actually, you know what? Not someone. If we're working on this, and since y'all are here, I know you are, FOIL number 6 for me. Separate problem, unrelated to what is being asked of us, but I want to see this thing FOILed out, aka distributed. And we know that this is FOIL eligible because it's 2 binomials. So 5x minus 10 times x plus 2. I'm going to give you all like 30 seconds to try to FOIL it. After which, I'm going to go and give you all the answer if you didn't get it. Here's our first step. Ready? Make this FOIL a little bit smaller so I can use my rainbows. 5x times x, 5x squared. Outside times outside, 5x times 2, 10x. By the way, this is what we did last week. If you missed it, this is what we learned in terms of multiplying binomials or multiplying polynomials. -10 times x is -10x. And last but not least, -10 times 2 is -20. From here, we combined like terms. Great call, Francis. Good job. We combine like terms. Do we have any like terms? Sure do. 10x and -10x. What do those things do to each other? Cancel each other out. Boom, boom, boom. That's our FOILed outcome, by the way, y'all. Go back to our black. So really, the long story short is that these two, 5x squared minus 20, and that set of parentheses are the same thing. So truly speaking, these two equations in number 6, those two are equivalent. They're the same exact equation. Like legitimately, they are interchangeable. It's like saying my name is Mr. Benham and my name is Mr. B. Okay, different ways of writing it. One's a little bit shorter. So we could actually solve this equation in black by using opposites and inverses. What would I do to get rid of or solve this problem first? Does anyone know? If I said, hey, solve this thing, forget about what's above it. What should I do first to solve this? Anyone have an idea? Add 20. Great call, Francis. We know we're working with SADMAP. We always get rid of subtraction or addition first, just PEMDAS backwards. So we get rid of subtraction via addition, adding 20 to both sides. Cha-ching. Problem starting to become a little bit more like what we want to see. Now what? Divide. Get rid of that multiplication of 5. We divide by 5. Great call, Caitlin. Which then gets us even closer to where we want to be. And guess what? 20 divided by 5 is 4. Now is the hardest part. How do we get rid of exponents? AKA, what is the inverse or the opposite? Specifically, not of any exponent, but just specifically a power of 2, a square. How does one get rid of a square? X squared is equal to 4. What squared is equal to 4? Anyone know what the inverse of a square is? You're right, the answer is 2, for sure. Yeah, the answer is 2, but the reason that, or the way that we could find this if we didn't know that, is by using the inverse of a square, which is a square root. Square roots, great call, Sydney. Get rid of squares. That allows us to see Francis's answer of the square root of 4, or what times itself is 4, is 2. Nice, man. Good. Cool. So that is one way to solve this problem. Sweet. Another answer to the square root of 4, by the way, could be -2. Because think about it like this, -2 times itself does give you what you were square rooting for. So we'll keep that fresh in our mind. What we just did, y'all, is we used foiling, what we talked about last week, to get to here. And then we used all the work that we've done this year together to solve by undoing opposites with addition, with division, with square roots. We already know the answer. I'm going to eliminate all this work. And we're going to solve it with the zero product property because guess what? It's actually going to be easier in this case. But we're going to talk about, I did this for a reason. There's a method to my madness. I want to move our answers up here. These are checked work. Okay, zero product property says you have a multiplication problem, and we do. Parenthesis in red times parenthesis in green. If the multiplication problem is equal to 0, and it is, it's our favorite type of multiplication problem because all we got to do is take our parentheses individually, aka we take our factors, the things that are being multiplied, and we set them equal to 0. So we do this, boom, 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 boom. I'm going to solve the green one first because all you got to do is get rid of addition with subtraction. X equals -2. Okay, I see you. I see you, -2. And then we could use our logic of addition and division, a la what we did on the check problem originally, and say, all right, get rid of subtraction. Let me zoom back out a little bit. With addition, adding on both sides. 5x is now isolated on the left. It's equal to 10. X is not by itself, so we use division. Boom, boom. X is equal to 2. Okay, sweet. Now, the reason why we went through the process of foiling wasn't to get checks before solving it. I think I would agree personally that the zero product property was easier because the factors were already laid out. But it was for twofold. I want to go back and I want to talk about every single one of these problems real fast. Number one, how many answers did we have? 3. Why did we have 3 answers? Because there were 1, 2, 3 factors. Okay. Number 2, how many answers did we have? 2. The 2 are right here. Look at, boom, 16.5 and 109. Why did we have 2 answers? Because there were 1, 2 factors. There were 2 parentheses. Okay. You get it. How many answers did we have in number 3? 3, 0, 4, and -5. Can you take a guess as to why there were 3 answers? Because there were 3 factors, 3 multiples. 1, 2, 3. How many answers did we have in number 6? 1 answer, which was 2, a second answer, which was -2. We had 2 answers because we had 2 factors. And the final big bomb drop of this entire kind of section, which we'll learn a little bit more about on the upcoming weeks, days and weeks, is that anytime you have an equation like this one right here, which was the FOILed form, okay? The highest power, the highest exponent, power of 2, tells you the possible number of answers, the possible number of roots, or to kind of combine it all in terms of our Edpuzzle speak, the values of x that make everything equal to 0, aka our x-intercepts or our roots. So when you have a second power function, a power of 2, something to the second power, you should theoretically have the possibility of getting 2 answers. In this case, we did. So next but not least, or I guess maybe not last but not least, we still have a little bit of time left. Let's take a look at number 7. Okay, I'm going to tell you right now there's going to potentially be 2 answers to this, okay? Bear with me as it gets a little bit kind of wonky here. But I want to see if anyone knows what the answers or answer, depending on how you view it, is for number 7. I picked number 7 purposely because it's a little bit different than those that we've done so far. Notice we do have an equation equal to 0, yes, and we do have a multiplication problem. It just doesn't look like we're used to. They use the idea of an exponent, a power of 2, to imply repetitive multiplication. So on that note, I'm going to shut up for like 30 seconds. We'll see if anyone gets the answer to number 7. Super close, Francis. Oh, yeah, sorry. I thought your answer was -2. Yes, you do want to use the exponent and the x minus 2, 100%, which is actually going to lead you, if you do it correctly, to what Caitlin and Sydney just gave us. The answer to this is 2. So there's a few different ways of thinking about it. One, if you know, and great job, girls, by the way, and great question, Francis. If you know x minus 2 is being squared, that's just a shorthand way of saying x minus 2 is being multiplied by itself. Literally the same exact thing. Great call, Christian. If x minus 2 is being squared, it's x minus 2 times x minus 2, and guess what? Now we're game on, because guess what? We have zero product property implications here. We could set the factors, x minus 2 and x minus 2 equal to 0. We add 2, I'm doing this rapid fire now, y'all, but we add 2 to all sides, gone, gone. X is equal to 2, x is equal to 2. Now notice there were still 2 answers here. Answer number 1, answer number 2. What do you notice about the answers? They're the same. This is like a parabola that has a root or an x-intercept, an x value that gets you a height of 0, an x that makes the y equal to 0, where the vertex is on the x-axis. It's called the double root, or where you have one answer that shows up twice. It doubles up. There's another way of doing this also, by the way. Some of you may not like zero product property. Well, if you didn't, and you didn't like getting the answers via green, you could totally get the answers the following way, and that's by using opposites. Here's the same equation in purple. In PEMDAS, we would do parentheses first, but we don't know what that value is yet. Okay, so what we have to do is, to solve this, we have to use SADMET. And in SADMET, this everything like the subtraction is buried inside the parentheses. So really we can't get rid of subtraction, addition, division, or multiplication. So we have to get rid of the exponent first. Anyone recall what the opposite of a power of 2 is? Sydney actually just told this to us about 2 to 5 minutes ago, somewhere in that range. The opposite of a square root, a square is let's use a different color than green. So the opposite of a power of 2 is a square. So when we square root something squared, it gets rid of it. It undoes it, like addition undoes subtraction. What's the square root of 0? AKA what times itself is 0? 0. And then we add 2 to both sides, and guess what? We get the very same answer, that x is still equal to 2. And Francis, you're right, 2 does equal 2. They're the same answer. So long story short, it told us the number of answers we would get, 1, 2, and we could use a variety of tactics to do so. I personally just like to work with a zero product property. It falls in line with what we're working with a lot in this unit. So on that note, open-ended question number 10, using what we just discussed and what we kind of talked about way back in probably September, which was actually our introduction to this lesson. Can anyone create an equation with the following constraints, the situation? Create an equation that has 53 and 22 as its only solutions. All right, Caitlin, I see you. Great job. She basically took the fact, she said x minus 53 and x minus 22, set it equal to 0. Perfect. Because if you set each one of these individually equal to 0, they would give you exactly what the solutions we were looking for were. So Caitlin, great job. That is one equation that could have the solutions of only 53 and 22. And notice there were 2 answers. So we had 2 parentheses, or 2 factors. Great job, Caitlin. All right, you're crushing this. Let's see, we have about 5 minutes left. Let's see if we can move on to number 11, 12, and 13. Does anyone still need me to keep it on number 10? Speak now or forever hold your peace. All right, here we go. Numbers 12 and 13, these are review. We're doing what here? Multiplying, AKA foiling. Here we go. X times x, x squared. Anything times itself is always Squaring. What's the opposite of a square? Square root. Keep that in mind. X times 1, 1x. Ooh, I like this. Negative 1 times x, negative 1x. Why do I like it? That's going to be useful in a second. Okay. On to the next. Negative 1 times 1 is negative 1. Now, why did I say I liked it so much? Because of my like terms. I know some of you might have noticed that when we FOIL, those O and the I, the vowels of the mnemonic device FOIL, are always like terms, FYI, in these cases. And Caitlin is 100% correct. These two cancel each other out, leaving us with just the first term, x squared, and the last term, negative 1. Do I need to solve this? No. Why not? No equal sign. You only solve when you're looking for a relationship or an equality when you have an equal sign. Sweet. Okay. Number 13. Here we go. Rapid fire time. Ready? X times x, x squared. X times 5, 5x. Negative 5 times x, negative 5x. And last but not least, negative 5 times 5, negative 25. Why is this so awesome? It cancels out again. Look at those. Okay, cancels out. See ya. Just x squared minus 25. Now, this is actually, for those of you who love shortcuts and love quick memorization shortcuts, number 12 and 13 are what we call difference of cubes. I'm sorry, difference of squares, excuse me. And difference of squares are situations where you have a difference, aka a subtraction sign, of two things that are perfect squares, applications of something times itself. And here's the trick. If you ever see, and look at numbers 12 and 13, if you ever see multiples, the binomials, the parentheses that have the same variable x and the same number, like 1 and 1, but have opposite operation signs, the middles will always cancel each other out. It's a shortcut. So what I mean by that is I could do 15 real quick, and I say, all right, the answer to 15 is going to be this. Because the plus and minus of the same number cancel out that middle term. Number 16 is going to be the first term, b times b, and then negative 6 times 6. It's rapid fire. I could do it all day if we wanted to. 19, c times c, 2 times negative 2. Anytime you have a multiplication of the same numbers and variables but opposite operation signs, plus and minus, you just take the firsts and the lasts. Works 100% of the time, every time. That is simply just a shortcut. And on that note, although we did not get to the last two problems, 25 and 26, let's see what those are all about. Oh, we could do 25 real quick. 26 is just a review problem. Notice same terms, 2x, 2x, 3 and 3, just opposite operation signs. And what I mean by that is plus and minus. We just take the first term, 2x times 2x, 2 times 2 is 4, x times x is x squared. And last times last, negative 3 times 3 is negative 9. Also works with FOIL 100% of the time, every time, but that's just a shortcut. All right, then, y'all, if you don't have any questions, we're going to wrap it up here today. If you want to stick around and say what's up or just kind of reiterate what we were talking about before class, you're welcome to. I'm going to stop the recording right now. And then if you're going to take off, I will see you all on Thursday. Have a great rest of your day. Have fun. Be safe.